Hello my dear students, welcome to maths class. Last class we discussed triangle and circle. Do you remember? Yes, that is the length of a chord can be determined by its central angle. Okay, that is if the central angle is C and the radius of the circle is R, then length of this chord, this is the chord, and length of this chord is equal to, that is 2R sine C by 2, that is 2 times of the radius into sine of half of the central angle. We discussed this result, right? Now we are extended this result to find length of sides of triangles. Okay, we are going to extend this result to length of sides of triangles. Here we have a triangle. Okay, that is ABC is a triangle, and here we have some angles. That is the measurement of the angles. Angle A is equal to 65 degree and angle B is equal to 55 degree and angle C is equal to 60 degree. Okay. Now using the result between the circle and triangle, how do we find the length of the sides of this triangle? Okay. For that, here I am going to consider the circumcircle of this triangle. Okay, circumcircle of this triangle. This is the circumcircle of this triangle. Right? This is a circumcircle of the triangle. And now all the three sides, that is this AB is connecting 2 points of the circle. A, B and C are 3 points on the circle, and AB is a line connecting 2 points, BC is also a line connecting 2 points on a circle, and AC is also a line connecting 2 points on the circle. Okay, so all these are called chords, right? That means the sides of the triangle are chords of the circle. Right? All these are chords of the circle. Now, if we find out the central angle of every chord. Okay, central angle of every chord. How do we find the central angle of every chord? Let us check. See, here we have this chord. This chord make an angle 65 in the alternate arc. Right? This is the alternate arc of this arc, right? So if we join the ends of the chord to a point on the circle, we get an angle half of the central angle, right? That is, the central angle of this chord is double of the 65 degree, right? So we have this angle is equal to 130 degree, okay, double of 65. Similarly, if we consider the chord AC, and it is joined to a point in the alternate arc B, we got an angle 55 degree. Okay, then what will be its central angle? This is the chord, and in the alternate arc 55 degree, then its central angle is equal to double of this 55, that is equal to 110 degree. Okay, similarly, the last chord is AB, and this AB make an angle 60 degree in the alternate arc. Then its central angle is equal to, yes, 120, double of 60. Okay, so these are the central angle of the chords AB, AC and BC. Okay. Now using our 2R sine C by 2, can we find out the length of the triangles, sides of the triangles? Yes, we can find out, right? What is BC? Yes, BC is equal to, yes, 2R sine C by 2. What is the central angle of BC? 130. So 2R sine C by 2 means 2R sine C by 2. C is 130 and its half is, yes, 65. So we have yes, BC is equal to 2r sin A. Okay, A is 65 degree. That is, this side is equal to 2 times of the radius into sine of the opposite angle. Okay, sine of the opposite angle. Similarly, yes, what is AB? Length of AB is equal to, yes, AB is equal to 2r into, yes, sine half of the central angle. Half of the central angle is 60, right? That is equal to 2r sine B. Okay, similarly, AC is equal to 2r sine C. Okay, 2r sine C. That means if we need a length of the triangle, yes, we just multiply double of the circumradius. See, this is the circle of the triangle. So, double of the circumradius into sine of the opposite angle. Okay, double of the circumradius. This is the circumradius into 2 times of the circumradius into sine of the opposite angle. Okay, sine of the opposite angle. We got all these angles like this. See, here we have this triangle. Yes, all the angles are less than 90 degree, right? 65 less than 90, 55 less than 90, 60 less than 90. That is, all the three angles are less than 90. These type of triangles are called the acute angled triangles. Okay, acute angled triangles. So this one is an acute angled triangle. So in an acute angled triangle, the sides are, yes, what are the sides? Sides can be determined using the radius of the circumcircle and sine of the opposite angle. Okay, that is, every sides of an acute angled triangle, is the product of 2 times of the circumradius and sine of the opposite angle, if the triangle is an acute angled triangle. Okay, now if the triangle is a right triangle, what happens? Let us discuss. Here you can see a right angled triangle, and we know that in a right angle triangle, one angle is equal to 90 degree. Suppose here we have other two angles are 40 degree and 50 degree. Okay. Now, if we consider its, yes, if we consider its, okay, if we consider a circumcircle, yes, what is this side? The side opposite to 90 degree. What is the side opposite to 90 degree? Yes, we know that from the chapter circles. We know that in a right triangle, the side opposite to 90 degree is, yes, the diameter of the circle. Right? That is, here we have the diameter, or this is the circumdiameter. So this side is equal to, yes, 2r. That is the side opposite to the diameter. Okay, sorry, the side opposite to 90 degree. And what about this side? Yes, this side, its central angle is, yes, its central angle is equal to 80, right? And using our formula, we have this side is equal to 2r sine 40, right? 2r sine 40. And what about the side opposite to this angle, 50 degree? Yes, this side is equal to 2r sine 50, right? 2r sine 50. So, in a right triangle, yes, one side is, the side opposite to 90 degree is the diameter of the circle, and other two sides are, as we did in the earlier problem, we just write 2r sine of the opposite angle. Okay, here also 2r sine of the opposite angle. Okay, in a right angle triangle. And if the triangle, two types of triangles we discussed, which are, one is an acute angled triangle. Acute angled triangle means all angles are less than 90. Okay, all angles are less than 90. Then, what do you mean by a right triangle? A right triangle means, yes, one angle is 90. One angle is 90 and other two angles are less than 90. Okay, other two angles are less than 90. That is called right triangles. Then one more type triangle is there, which is that, yes, that is an obtuse angled triangle. Okay, obtuse angled triangle. Next is an obtuse angled triangle. So so far we discussed acute angled triangle and right triangle. Now we are going to find out the ratios of the sides of an obtuse angled triangle. Okay, so here I am going to draw one obtuse angled triangle. Obtuse angle means what? Yes, one angle is greater than 90 degree. Okay, one angle is greater than 90. One angle is greater than 90 and the other two angles are obviously less than 90, right? Because sum of three angles should be 180 degree. So if one angle itself is more than 90, then other two angles should be less than 90s, right? So if we take this angle as, yes, suppose this angle is equal to 110 degree and this angle is equal to 30 degree and this one is equal to 40 degree. Okay, 40 degree. Then suppose here also we have a, yes, we have a circumcircle like this. Okay, circumcircle like this. Then first I'm going to name this as ABC. Okay, then we know the side opposite to 30 degree. In acute angle triangle we know that the sides are, yes, sides are 2r into sine 30. The side opposite to this 30 degree is 2r sine 30, right? And the side opposite to this 40 degree is 2r sine 40. Okay, but see here we have an angle 110 degree. 110 degree. So can we take this as 2r sine 110? Is it possible? No. Why? Because we have the sine values only up to 90 degree. Okay, we have the sine values only up to 90 degree. Then how do we solve this? Yes, for that, yes, we are making use of the idea of alternate arc. The angles in the alternate arc are supplementary, right? So I am just going to join, yes, the ends of this chord BC to the other arc or the alternate arc of this BC. Okay, we just take this angle and we know that a chord make two angles on either side of it. That two angles are supplementary. Do you remember that? Yes, that angles are supplementary. Then what is the supplementary angle of this 110? Yes, that is equal to 70 degree. Okay, 70 degree is a supplementary 70 degree is the supplementary angle of 110 degree. Okay, now see here, if we consider this triangle ABC, this BC, we need this side BC, and this BC is also a side of this triangle BDC, right? This triangle BDC, for this triangle BDC, the side BC is a common side. Okay, for both the triangles, the side BC is a common side. So now we have this angle is less than 90 degree. Okay, less than 90 degree. So we can find out this length as yes, 2r sine 70, right? So if one angle is greater than 90 degree, yes, we just take 2 times of the radius into sine of its supplementary angle. Okay, sine of its supplementary angle. If one angle is greater than 90 degree, then we take 2r into sine of its supplementary angle. This 70 is the supplementary angle of 110. What do you mean by supplementary? Sum of two angles is equal to 180. They are called supplementary angles. Okay, now we have some problems based on this. Let us do the problems in page number 114. Okay, 114, first question. So this is the first problem. The figure shows a triangle and its circumcircle. Okay, what is the radius of the circle? So we need the relation. What is the relation? Yes, 2r, every side of the triangle is 2r of sine of its opposite angle. Okay, 2r of sine opposite angle. That means length of this chord 3 centimeter. That is, this is the length of the chord 3 centimeter. That 3 centimeter is actually, yes, 2r into sine of its opposite angle. Right? Sine of its opposite angle is 60. So 2r sine 60. Okay? 2r sine 60. From this, can we find out this r? Yes, we need the radius of the circle. How do we find this? Yes, for that, yes, keep this r only here. Move all other things to this side. Okay, so we have, yes, here we have keep r on one side and the other things on the other side. Okay, we move the other things to the side of 3. Okay, so I'm just write this r first. Okay, that is, if we have the equation like this, 2r sine 60 is equal to 3, then move all other things to the right hand side of the equation, that is excluding this r. Okay, so we have 3 and this 2 is multiplied here, that is by 2, and this sine 60 is also multiplied here, so that is equal, that is also divided by, so 2 into sine 60 goes to the division part. Okay, so 3 by 2 sine 60. And what is the value of sine 60? Yes, sine 60 is equal to root 3 by 2. Just substitute that. That is 3 by 2 into root 3 by 2. Okay, so first we are cancelling the denominator, that is 2 and 2 get cancelled. Then here we have 3 by root 3. Okay, and we know that this root 3 is actually root 3 into root 3. Okay, so that is equal to divided by root 3. 1 root 3 get cancelled, then we have root 3. That is, radius of the circle is equal to root 3 centimeter. Okay, radius of the circle is equal to root 3 centimeter. Clear? Our next question is second question. What is the circumradius of an equilateral triangle of side 8 centimeter? Okay, what is the circumradius of an equilateral triangle of side 8 centimeter? Okay, all the sides are 8 centimeter and all the angles are 60 degree. Okay, then how do we find? Yes, this side is equal to, yes, the side is equal to 2 times of the radius into sine 60. Okay, that is this 8 centimeter. All the 8 centimeters are equal to 2 times of the radius into sine 60. From that we can find out the radius of the circle. Okay, that is 2r into sine 60 is equal to 8. Okay, 2r into sine 60 is equal to 8. Then first, yes, keep this r on this side and move all other things to the other side. That is 2 into sine 60. Okay, so we have 8 by 2 into root 3 by 2. 2 into root 3 by 2. 2 and 2 get cancelled. Then we have 8 by root 3. So the radius of the circle is equal to 8 by root 3 centimeter. Okay, now we have the third question. Okay, do the third and fourth problem as homework. Okay, now I am going to do the fifth problem. Here we have another question. The picture shows a part of a circle. What is the radius of the circle? Okay, so this triangle, if we consider this triangle, what type of a triangle it is? Yes, this one is an obtuse angled triangle. That is, one angle is equal to 140 degrees. So that is an obtuse angled triangle. In the case of obtuse angled triangle, the side opposite to the obtuse angle is, yes, side opposite to the obtuse angle is, yes, 2r into sine of its supplementary angle. What is the supplementary angle of 140? Yes, supplementary angle of 140 is, yes, 40. Okay, supplementary angle of 140 is 40. So this side 8 centimeter is 2r into sine 40. Okay, 2r into sine 40 is equal to 8. Then What is R? R is equal to, yes, 8 divided by 2 into sine 40. Okay, substitute the value of sine 40 and find the answer. Okay, this is equal to, yes, 8 by 2 into 0.6428. Value of sine 40 is 0.6428. So let us cancel this 2 and 8 first. That is 4 by 0.6428. I hope all of you know how to divide a natural number by a decimal number. If you have any doubt, you can call me. So, and its answer is, yes, this answer is equal to 6.22 centimeter. Okay, 6.22 centimeter. Okay, children. So, today we discussed a lot of things. Study well, children. Thank you.